In Objective 3, we're going to be looking at some different types of equations. So far, every equation that we have solved using our 7 steps has ended up at the end with one single answer. By the time we go through all of these steps, up to step 6 here, we end up with our variable on one side and a number on the other. And most of the equations that we work with in this class, that will be the case. But there are a couple of exceptions, so we need to cover those as well. So as I just mentioned, most equations that we solve in this class have only one solution, where you get to the end of the problem and you get x equals, and then there's a number here. But there are also some times when the variable drops out. Okay? And by that I mean that you end up with an equation with 3x on one side, 3x on another side. When you subtract, or when you try to bring all your variable terms to one side of the equation, they end up canceling each other out and the variable term disappears. So two things can happen when that variable term drops out. Sometimes the variable drops out and you get a false statement. And what I mean by that is that the numbers that are left, you could have 3x minus 7 on one side equals 3x plus 2 on the other side. The variable terms drop out and you end up with the statement negative 7 equals 2. Well, negative 7 doesn't equal 2. So that's what we call a false statement, and that means that that particular equation does not have a solution. So the way that we shorten, since mathematicians are lazy and don't want to do extra writing, when you get a false statement like this, two constants that are supposed to be equal to each other that obviously aren't, you're going to write the answer no solution by making a circle with a slash through it. That does not mean the same thing as 0. That 0 with a slash through it is the symbol used in mathematics to mean no solution. The other thing that can happen when all the variable terms drop out is that you end up with a true statement. For instance, if we had 3x plus 5 on the left side and 3x plus 5 on the right side, when we go to gather all our variable terms to one side, the variable terms drop out, and we're left with 5 equals 5. Well, 5 equals 5 is a true statement, and it is always true. That means that no matter what value you put in your original equation for x, you're always going to get a true statement at the end. We call that an infinite number of solutions, and the symbol that we use to represent it is this funny looking letter R. You make a capital letter R with two lines in the front. You could also think of it like the paragraph symbol from English turned into an R because it's got that tail on it. And that is the symbol in mathematics for all real numbers, because any real number put into this statement, whether I put in 7, negative 12, positive 1 and 5/10, 36, your grandma's birthday, it's always going to come out to be true. So let's look at a couple of examples of those. In the first problem, these will feel kind of easy after the decimal fraction ones we just finished. I'll distribute the 4 through. That'll give me 8p minus 28. I'm going to combine my like terms on this side. 9p plus 4 equals 9p minus 28. And now I'm ready to move all my variable terms to one side. When I move the 9p over here to the right, or the left, I discover that the variable term drops out, leaving me with the statement 4 equals a negative 28. Well, since 4 doesn't equal a negative 28, the solution to problem 40 is no solution. It doesn't have one. Let's look at one more example. 3y plus 16 equals 5y. I'm going to distribute that negative 2 through, so I have a negative 2y, and a negative 2 times a negative 8 is a positive 16. I combine my like terms on the right side. 5y, take away 2y, leaves me with 3y. Oops, I said 16, I think I wrote 6, plus 16. Then I bring all my variable terms to one side, subtracting 3y on both sides. Once again, the variable term drops out, and I'm left with 16 equals 16. Since that is a true statement, 16 does equal 16, this equation's solution, the solution to problem 41, is infinite solutions, or all real numbers, represented with the funny looking R.